Hi, I'm Rachel, and today we're going to be talking about ionic and covalent bonds, covering these key areas: the formation of ions, ionic bonds, covalent bonds, and dot and cross diagrams. So what is an ion? An ion is defined as an atom or molecule that has gained or lost one or more of its valence electrons, giving it a positive or a negative electrical charge. So electrons have a negative charge overall. So the gain or loss of one or more electrons enables the atom to achieve a full outer shell, so a complete octet, which is equal to a noble gas configuration. There are two types of ion. A cation is an atom which has lost electrons, forming a positively charged ion. So these are indicated by the plus sign, for example, Ca2+. And most metals form cations because of their position within the periodic table and also their electron configuration. So an anion is an atom which has gained electrons to form a negatively charged ion. So these are indicated by the minus sign, for example, Cl-, and are most nonmetals, and all halogens form anions. So the valence of an ion is equal to the number of electrons lost or gained. Now there are many differences between atoms and ions. So atoms are the smallest unit of matter which make up an element, so they can't be broken down. Atoms are neutral in terms of charge as they contain the same number of protons and electrons. Ions contain different amounts, so they are atoms that have become charged. Molecules are a combination of atoms, and compounds are a combination of ions. Ions are stable as they have a complete octet or outer shell. Atoms are unstable as they don't. Atoms can take part in chemical reactions. Ions are part of ionic reactions. And atoms can form a covalent bond or an ionic bond. Ions can only form an ionic bond. So what is an ionic bond and how do they form? An ionic bond is a transfer of one or more electrons from one atom to another. So this results in the formation of two or more oppositely charged ions electrostatically bonded together. So because anions and cations contain opposite charges, they are electrostatically attracted to each other. So cations repel other cations, anions repel other anions, and because of their attractions and repulsions, they are a very reactive species. So ionic bonds form between metals and non-metals, cations and anions. And ionic compounds have very high melting and boiling points. They're hard and brittle with a lattice-like structure, so they're quite hard to break. This is an example of a sodium chloride ionic bond. So sodium has one valence electron in its outer shell. So it loses this electron to form a positive cation, Na+. The chlorine atom has 5 valence electrons, so it needs 1 to complete its outer shell. So the sodium atom gives the electron to chlorine to create a full outer shell and a negative anion, Cl-. So the positive sodium ion and the negative chloride ion are electrostatically bonded together to form Na plus Cl-. So in ionic bonds, the net charge of the compound must always be 0. Covalent bonds are a type of chemical bond characterised by the joint sharing of valence electrons with other atoms to achieve a full outer shell octet. So a covalent compound is a molecule held together by covalent bonds. So they have identical or relatively close electronegativities, so they're non-metals. The electrostatic attraction occurs between a positively charged nucleus and a pair or more of shared negatively charged electrons. So the example here shows hydrogen chloride, and it is a dot and cross diagram. So they represent the electrons in an atom as either dots or crosses depending on which of the reacting atom they come from. So the circles indicate the outer shell of electrons, and where the circles overlap is a covalent bond. So the properties of a covalent bond. They are weaker than ionic bonds, they are softer and flexible and require less energy to break. They're gases at room temperature and have low melting and boiling points and are poor conductors of electricity. Elements will share electron pairs until each atom in the compound has 8 valence electrons, apart from hydrogen, as hydrogen can only contain 2 electrons. The electron pairs are called bonding pairs or shared pairs and allow each atom to achieve a stable outer shell. So there are 3 types of covalent bond. The first is a single covalent bond in which it shares a single pair of electrons. So this example here on the left is the formation of a covalent bond in H2O water. So each hydrogen atom has 1 valence electron. It needs 1 to complete its outer shell. Oxygen has 6 valence electrons, so it needs 2 to complete its outer shell. So each hydrogen atom shares 1 electron with oxygen, and oxygen shares 2 valence electrons with hydrogen, creating a single covalent bond between hydrogen and oxygen. So this creates H2O. The second example is a double covalent bond in which 2 pairs of electrons are shared. So this example shows a double covalent bond between 2 oxygen atoms. So we know that oxygen has 6 valence electrons. So each oxygen needs 2 electrons to complete its outer shell. So each oxygen atom contributes 1 electron to each of the bonding pairs, resulting in 2 covalent bonds between the oxygen atoms, forming a complete outer shell and a double covalent bond. The third type of covalent bond is a triple covalent bond, which is a sharing of 3 pairs of electrons. So the first example shows a nitrogen molecule. Now each nitrogen atom has 5 valence electrons, so it needs 3 more electrons to complete its outer shell. So each nitrogen shares 3 pairs of electrons with other nitrogen in order to obtain a full outer shell of electrons, forming a triple covalent bond known as N2. The second diagram is a carbon monoxide molecule. So carbon has 4 valence electrons, so it needs 4 to complete its outer shell. Oxygen contains 6 valence electrons, so it needs 2 to complete its outer shell. So oxygen shares 4 electrons with carbon, and carbon shares 2 electrons with oxygen in order to obtain a full outer shell and forming a triple covalent bond known as carbon monoxide. Now, a coordinate dative covalent bond is where one of the atoms shares both of its electrons to the covalent bond. So one of the atoms shares no electrons. So the example on the left shows an example of a coordinate covalent bond between ammonium and a hydrogen ion. So ammonia, NH3, and hydrogen, H+, bond together to form NH4+. So hydrogen has no valence electrons in the ion because it is a cation. It has lost its electrons. The electron configuration of nitrogen is 2,5. It has 5 valence electrons. So when ammonia, NH3, is formed, it forms 3 nitrogen-hydrogen single covalent bonds, as you can see in the diagram. So nitrogen has 2 unpaired electrons. So what happens to form the dative covalent bond is those 2 electrons are shared with the hydrogen ion to form the bond NH4+. So to summarise, an ion is a charged particle as it contains cations, which are positive, and negative anions. Atoms are neutral in terms of charge. An ionic bond is the transfer of electrons from one atom to another, resulting in 2 or more oppositely charged ions electrostatically bonded together. Covalent bonds are a chemical bond characterised by the joint sharing of valence electron pairs between atoms to achieve a complete octet. There are 3 types of covalent bond: single, double and triple. Covalent bonds are weaker than ionic bonds, and dot and cross diagrams are used in covalent bonds to represent the electrons in an atom. Thanks for listening.